Section 1. Introduction to the 8085 microprocessor. The 8085 microprocessor is a marvel of technology. It is the brain of many electronic devices. This 8-bit microprocessor was popular in the 1980s. Even today, it is important for understanding microprocessors. The 8085 has 40 pins. Each pin has a specific function. Understanding these functions is crucial for designing and interfacing with microprocessor systems. This essay will explain the functions of each pin in the 8085 microprocessor. This knowledge is essential for budding engineers. You will learn how to connect the 8085 to other devices. This includes memory chips, input-output devices, and other peripherals. So, let's dive in. Section 2. Power supply and clock signals. Let's start with the basics. Power and clock signals. The 8085 needs power to function. Pins 40, VCC, and 20, VSS, provide this power. VCC is the positive supply voltage, 5 volts, while VSS is the ground, 0 volts. The clock signal is like the heartbeat of the microprocessor. It synchronizes all operations. The 8085 uses a two-phase clock, X1 and X2. Pin 1 is for X1, the high-frequency clock input. X2, pin 2, is generated internally. For example, in a lab setup you might use a crystal oscillator connected to pin 1 to provide the clock signal. A simple experiment could involve varying the crystal frequency and observing its effect on the execution speed of instructions. Section 3. Address and Data Bus. The 8085 uses an address bus and a data bus to communicate with other components. The address bus is like a postal address. It tells the microprocessor where to find the data it needs. The 8085 has a 16-bit address bus. This means it can access up to 65,536 different memory locations. Pins A0 to A15, multiplexed with the data bus, form this address bus. The data bus is like a highway. It carries the actual data between the microprocessor and other devices. The 8085 has an 8-bit data bus, pins AD0 to AD7. It can handle 8 bits of data at a time. In a practical lab setting, you might connect a RAM chip to the 8085. By writing and reading data from specific memory locations, you can understand how the address and data bus work together. Section 4. Interrupts, DMA, and serial I/O. The 8085 has several pins dedicated to handling interrupts, direct memory access, and serial input-output. Interrupts are like external triggers that interrupt the microprocessor's normal flow of execution. Pins RST5.5, RST6.5, RST7.5, trap, INTR, and INTA are all related to interrupts. DMA allows certain devices to access memory directly without going through the microprocessor. This speeds up data transfer. The hold and HLDA pins are used for DMA operations. Serial I/O enables communication with devices using serial data transmission. The SID, serial input data, and SOD, serial output data, pins handle this. For example, you can simulate an interrupt by connecting a button to one of the interrupt pins. Pressing the button would generate an interrupt signal, causing the 8085 to jump to a specific interrupt service routine. Understanding these advanced features is crucial for designing more complex microprocessor-based systems.